Okay, here we go. This is, I guess, part 4 altogether, but it's part 2 for today. Today's actually, let's say the date. What is it? Monday, the 26th of April. All right. And it's rainy. It's cold. It's dreary. Set the scene, you know. All right, here we go. I said we were going to fool around anymore. All right, marker. Now, I converted from degrees to radians. All right, you saw that. And then you could do that with any angle at all. It doesn't even have to be one of these special angles. It could be like 74 degrees if you wanted to. All right, it'd be a little ugly. It wouldn't come out nice and perfect, you know, as far as a fraction, but you could still convert it to radians. Let's do this. Let's convert from radians to degrees. Let's take this right here. Let's take the 3 pi over 2. That one looks a little odd compared to all the rest of them. So let's convert that one, and since we're converting the other way, let's just change to another color. Let's go green. So let's go 3 pi over 2. 3 pi over 2. Now here's, again, this could be a question in the book. It says 3 pi over 2, and you want to convert that into degrees. So we're going to multiply it by one of the, unit multipliers is what that other book called this thing. Unit, because unit means 1, all right, multiplying because we're taking this, a 1, and we're multiplying it by something. So we call that a unit multiplier. I don't think they talk about that in this book, but that's what I've learned it to be. All right, so 3 pi over 2, you got, this time you have pi on the top. Do you see that? So you could put pi where? On the bottom. I'll show you a little easier way than this. I'm not even going to go through the whole thing. You could do that. Or, okay, you could do this. That just kind of, it follows along similarly from what we just did up here. All right, that's why I did that. Or, this is kind of easy. When you go from radians to degrees, it's actually pretty simple. Because what is pi equal to? 180 degrees. So really, we could just do what? Just replace that pi with 100, substitute it, right, with 180 degrees. That's kind of easy, isn't it? So whenever you see pi, you can throw in 180 degrees, and you've changed it from radians to degrees. So let's do it that way. Either way would work, wouldn't it? Because if you look at it, look, pi and pi cancel. Basically, we're just taking the pi away, and we're sliding in 180, aren't we? So really, this does work. But I just think it's kind of easy just to do it like this. Think of it this way. So 3 times 180, and you divide that by 2. All right, let's see what happens. That goes once. This goes what? 90, right? 90 times 3 is 270 degrees, and that's what you told me, wasn't it? What that angle is right there in degrees. All right, so that's a nice, easy conversion. Would you agree? All right, simple. All right, let's do this. All right, look at that. That just popped up right there. What I've done is I've shown you, I know, I told you I'm weird on this thing. I'll get used to it. 30, 45, 60. Remember we talked about special triangles and 30, 60, 90 triangle, 45, 45, 90. Those are special angles that we deal with quite a bit. So what I've done is I did this beforehand. This would have taken me forever to do it in front of you guys. So I had this already done so you could see all the conversions from degrees into radians. Maybe we'll do 1 or 2 of these just to get an idea if that's really true. 0 degrees, of course, would be 0 pi radians. That's easy to see. Now, as you're going up here, this is 30 degrees right here, and that's pi over 6. Well, why in the world is it pi over 6? Well, let's come over here, and let's just use the red. So let's just do a conversion again. 30 degrees, just so you remember how to convert. And then we put degrees on the bottom, right? 180, and we put what on top? Pi. All right, and then we just work this thing out. So 30 goes once, 30 goes into this 6 times. There it is. It's pi over 6. Does that make sense? Why is pi over 6? Okay. Now I could do that for all of these, but you believe me, don't you? All right. These are just taken, well, they're taken from the book, but you could figure them out as well, right? And it tells you all these different degrees. Now look, remember we talked about one of the first lessons on this section talked about going in these other quadrants right here. So if I went to here, now this angle would be 30 degrees, wouldn't it? But really we call it 120 degrees because we start from the positive x-axis. Does that make sense? That's why that's 120 degrees. So we're starting here and we're going to all these different angles. That's why they're all these big numbers right here. All right, so those are important angles that we're going to deal with a lot. To tell you the truth, I probably should have some of these memorized, but I don't. If you told me what is 210 in radians, I doubt I could just tell you what it is right off the bat. Some of the other teachers might be able to, but I just haven't worked with radians as much. Just because in Algebra 2 we kind of stick with degrees a little bit more than we do with radians. So I'm not as familiar with these numbers as far as them being memorized as I probably should be, I guess. But really, does it really make any difference? I could take 210 and change it, couldn't I? So 210, that's degrees, and I put 180 here, and I put a pi here, and I work this out. Watch, the zeros go. What goes into both of these? 3 goes into this, right? 7 times. 3 goes into this, what, 6 times? Would you agree? 7 pi over 6. So it's really not that hard to figure it out, is it, if you don't have them memorized? So I'm not really going to say, okay, you have to have these memorized, but you should be able to convert from one to the other. Everybody with me on that? There is a picture in the book, okay, that looks very similar to this. If you want to, it's on page 819. All right, I think we're good on that part of it. Let's do one more thing, and we'll be finished. Let's click. I'll tell you what. Let's pause it. What's that? It's in the book. It's in the book. You can look. All right, here we go. We are going to do something a little bit different, but still has to do with angles and all that kind of stuff. We're actually going to take a look at the arcs. And let's first of all talk about what an arc is. You remember that from geometry, don't you?
Yeah.
Let's just mention it briefly.
Wow, thanks. That's on the internet.
What are you saying? You don't? Nah, you probably can't hear it. Paco said that Johnny failed all the chapters in geometry. And Johnny took offense to it, so just so you know what's going on in the audience. All right. Okay, here's a circle right here. If we talk about an arc, let's just do this real quick here. Whoops. All right. So if I had a radius go right here, and let's say a radius right here, we've already actually talked about an arc. We just didn't, I don't know, I might have mentioned the word. But this right here, this makes an angle as well as it's a distance around. So if that's theta right there, we call this arc theta as well. Remember that? We call it the central angle. Central angle is equal to its the arc that it cuts off. All right, so here's the arc and here's the angle. They're exactly the same, but it also has a distance, and that's what we're going to talk about. Now, if I talked about the distance from here all the way around the circle, what do I call that? Special math word, what is it? Circumference, right? That's the circumference around the circle. But we're going to talk about the length of the arc from here to here. Now, let's give this a shot again, just to draw it so we can notice. Now, this is not necessarily 1 radian. All right, come on. There, that's not too bad. All right, it's not as easy as it looks, so don't laugh. All right, so we're going to talk about this arc right here. We're going to actually talk about the arc length. Arc length. All right, so the actual distance. If the radius is in inches, we're going to talk about this arc length in inches. You follow me? Now, if this actually was 1 radian, and let's say this radius right here was 5 inches, then, and you knew this was 1 radian, then what would this length of the arc be? 5 inches, right? Because remember the definition of radian? Okay, very good. I was wondering if you're here. If this is 1 radian, then this would be 1 radian as well, which means it's the same length as this. Okay, I only have a minute and a half. Let's try to get this done in this one lesson. Here's the equation. By the way, we used arc length. We used S, all right, to represent arc length. Don't know why. In physics, they use S for distance quite a bit. Maybe that's why. All right, and it's just equal to r times theta. Pretty easy. You say, well, that's easy. Okay, if I know the radius and I know what theta is, now theta though, one reason anyway, we talked about radians is because this has to be in radians. To use this equation, theta has to be in radians. So if it's 30 degrees, you're not going to go 5 times 30. You follow me? Because 5 times 30 be 150. Is there any way that's 150 inches right there? That wouldn't make sense, would it? All right, and I'm running out of time. I got to go to one more lesson. Let's